We'll now look at the comparison test. So for the comparison test, we need two separate series that have positive terms. And if 0 is greater than a sub k, which is less than or equal to b sub k, and the summation of b sub k converges, then the summation of a sub k converges. So the idea is this b sub k, if I take this series of bk, then it's going to be a finite number. So something smaller than a finite number will still be a finite number. If 0 is less than b sub k, which is less than or equal to a sub k, and we know that b sub k diverges, then the series a sub k will also diverge. So now I know this b sub k is infinite, and if I have something bigger than infinity, it's still infinity. So now let's consider this one. If we look at just the k's, I have k cubed over k to the fourth, which would be 1 over k. So we may want to compare it to something like that. And we will. So we're going to start with the denominator and realize 2k to the fourth minus 1 is less than 2 times k to the fourth, which means 2k to the fourth minus 1, if I put that on the denominator, it's greater than 1 over 2k to the fourth. Multiplying both sides by k cubed gives me that k cubed over 2k to the fourth minus 1 is greater than k cubed over 2k to the fourth, which we can see is the same thing as 1 over 2k. And this looks an awfully lot like the harmonic series, which we know diverges. So we have something bigger than something that diverges. So it will also diverge. Next, we'll consider this series. So for this one, we're going to realize that for k greater than 2, the natural log of k is actually less than k. Dividing both sides by k cubed gives me that the natural log of k is less than k over k cubed, which is 1 over k squared. We know this thing converges by the p-series test. And now we see something smaller than something that converges, which means it must also converge.